Good afternoon. Nice to see you here. My name is Heinrich Schuchardt. I'm working for Canonical as a RISC-V software engineer. Canonical is a company behind the Ubuntu Linux distribution. And since last year, we have started really to support RISC-V like the other architectures, x86 and ARM, or PowerPC and S390. And RISC-V now is a fully supported architecture in the Ubuntu world. Out of the about 67,000 packages that exist for x86, 63,000 are available already for RISC-V. Last year, we offered pre-installed RISC-V images for the Unmatched and Unleashed board. Since this year, with the January release, we are offering an installer image, so you get the same experience when installing Ubuntu on RISC-V as you would get on any other architecture. With this January release, also moved booting to UEFI. But what I want to talk about today is containers, and we have enabled both building Docker and snaps for the RISC-V architecture. And I want to focus today on snaps, because snaps is really what's made for the embedded world, which is really made with IoT in mind. What are snaps? Snaps are containerized software packages which may provide either a service or an app. A container means that they come bundled with dependencies. So if you have different apps that may need different releases of certain libraries, it's good to have them in containers just to avoid conflicts between them. And snaps essentially work on on all the major Linux distributions. You can run them not only on Ubuntu, but also on Fedora, on SUSE, on Debian. What's great about snaps is that there's a marketplace where any developer can place his snaps that he has built and can then distribute them via this marketplace. And every time you turn on your computer or an IoT system regularly, they will be updated from this marketplace. You can just decide whether you want to be on the stable channel, on the edge channel, or on any other of the channels that are available. And those snaps, we use them on the desktop, for instance, for Firefox, but essentially they are also used for our IoT offering. So snaps are the basis for our Ubuntu core packaging of the Ubuntu operating system, where everything, including the kernel, is built as a snap. And it's really optimized for having IoT and or working on the edge. Made for IoT is because you get all the interfaces that you need in the IoT world, which you would have a problem to access from a Docker image, like you can access GPIO, I2C, or raw input, or raw USB. We are supporting a lot of different build systems, so it's not just for your C programs, but also if you have Go or Java applications, you can easily package those as a snap. I have brought along a small example just showing how easy it's to package something as a snap. It's not because it's the most complicated app, but I simply wanted to show what does it take to get a snap package. Just shows a simple example that you can see here at the booth. It's a power strip that you can control via USB. And there's already some software available, and I just did the packaging. And packaging just meant write one single file, one small YAML file to get it packaged. Then you take the Snapcraft snap from the Snapcraft store and just type Snapcraft, and it's being built. That's all you have to do. And what do you have to write? Or you write some metadata, of course. What's the name of your snap, license, version, some documentation maybe for the user where it gets interesting. It just says, where do you build on? It's built on Ubuntu 20. This snap, we want confinement. It's really important to have security, and security is provided by using namespaces, using C groups, and using app armor around it. Then you have to, of course, to describe what you are building. So this says, okay, I want to build a simple command, and what does it need? It needs access to USB. And this is just what the build instructions look like. So on the top you see from where is it downloaded. A checksum is used to be really sure that you take the right source and nothing that you haven't tested before. Then you say, okay, which build system do I want to use? So this one thing is built by using just configure, make install, using auto tools. So that is what I specify here. I didn't want to have the web server, so I just pass the parameter to the configure script. I tell it what build packages you need. I need the headers for the USB library. I need package config to find those includes and the library. And I need the auto tools for building. And then next thing that it says, okay, what you need is also at runtime a library. Yeah, and so you run just the snapcraft command, a VM starts up, the necessary packages are automatically downloaded in that virtual machine. The snap is built, and then with another command you just upload it to the snap store. This is what the snap store looks like, or my application looks like in the snap store. And this is where you can find hundreds of different snaps that already have been built. This brings me to the end of my talk. So if you want to try snaps on your own, just go onto this page and you will find all the instructions that you will need. If you are really thinking about IoT, remember that we really use it to package Ubuntu Core, and that we can offer you that you replace what you maybe today are doing with Yocto, and where you have to care for in the next 10 years about your Linux distribution. We could take care of it, providing Ubuntu Core for you and your device. Thanks a lot for your attention.